In September 1991, a dredging company replaced the wooden pilings around the Kinzie Street Bridge in Chicago. The pilings were supposed to protect the bridge and bridge house from the busy river traffic, but instead they would lead to one of the greatest structural disasters in Chicago history. 7 months later.
The first call came into the fire department about 2 minutes to 6 in the morning. And I had heard the fire department respond to water in the basement in the merchandise mart. Approximately 17 other buildings had reported flooding by 6:30.
And we're watching a strange story. Flooding reported in several Loop buildings this morning.
On April 13th, 1992, something catastrophic was going on in the commercial section of Chicago, known as the Loop. Water was flooding into the basements and rapidly rising.
The Loop is filled with office buildings, big corporations, the Board of Trade, the Mercantile Exchange, city and county government, state government, Marshall Fields.
It actually submerged 2 basements, which is about 40 feet of water. So yeah, that was quite astonishing.
The Chicago Fire Department immediately began evacuation.
The reason being was that there's transformers in the sub-basements of the buildings. Once the water reaches a certain level in the basements, they're going to short out the transformers, which will negate power to the buildings. In other words, you have no elevators, you have no fire protection.
More than 1 million people were forced to leave the Loop area.
The flood made it a ghost town. The center of Chicago is devoid of people. It was like a neutron bomb went off.
By 10 a.m., several hundred buildings in Chicago had been inundated.
Chicago Fire Department trying to determine where these water main breaks are coming from.
There was numerous reports of fish in the basements.
And I immediately said, I know where it's coming from. It must be the tunnel. All these older buildings had one thing in common. They were connected to the freight tunnel system and still had open entrances.
This is the freight tunnel.
The freight tunnel system is an underground labyrinth of passageways that runs for 60 miles under the city of Chicago.
We're 40 feet down below the city of Chicago, and you have this amazing network of tunnels down here.
In 1898, the privately owned Automatic Telephone Company got permission to build the tunnels. They planned to use them as a place to run the cables for their new dial telephone system. In the early 1900s, the tunnel project was expanded to include tracks for a small gauge railroad. The trains made deliveries to the basements of the stores and other businesses in the Loop.
They delivered coal for heating, they removed the ashes, they picked up parcels at the large department stores.
The tunnels were dug by hand, 40 feet below Chicago. The rail business reached its zenith in the 1920s, with more than 300 locomotives and 3,000 freight cars in operation.
I couldn't stop admiring the engineering vision, the commercial vision associated with it, and the workers who built it.
Some of the tunnels were built under the Chicago River. These had to be dug deeper than the underland tunnels to avoid the heavy river traffic.
There were about a dozen river crossings. They were about 60 feet below the surface level, or about 20 feet below the river itself.
On April 13, 1992, as the water continued to deluge the Loop basements, city emergency workers discovered an eddy, or small whirlpool, in the Chicago River at the Kinzie Street Bridge. The bridge was one of the areas where the freight tunnels ran underneath.
Knowing that the tunnel was 60 miles long and like 7.5 foot high and 7.5 foot wide, we knew we had a problem.
Emergency crews established that the tunnel under the bridge had been breached. They immediately tried to stem the flow of water.
We walked over to the river, and there in the river was a barge with fire department personnel on it, throwing mattresses and rocks into this whirlpool in the river.
It is clear that the city cannot live with a threat like this hanging over our heads.
As the crews worked to stop the flood, Mayor Richard Daley called in failure analysis experts to figure out exactly how and when the tunnel was breached.
The first most of the public heard about this event was the day it happened, April 13th of 1992. In fact, the events were set in motion in September of the prior year. During that time period, a company called Great Lakes Dredge and Dock Company had won the contract from the city of Chicago to replace some pilings that were used just on the south side of the Kinzie Street Bridge.
This work is routine work and not terribly complicated. What's required is that the old fender pilings be extracted and then replaced with new.
The pilings were clusters of 37 wooden stakes, each one 50 feet long. The dredging company was contracted to put the new pilings exactly where the old ones were. But when they got to the site, they realized that would be impossible.
There had been a tender house, which is hung on the side of the bridge, that had been moved. And if we were going to put the new pilings where the old pilings had been, we would have destroyed the house. So we asked for and were given permission to move 3.5 feet to the south with the new cluster of pilings.
The company completed their job in a week and moved on, unaware that they had placed the new pilings 3 feet closer to the freight tunnel than the old ones. This small move set the wheels in motion for the disaster.
When you drive a pile down through a clay soil, the clay has to be moved, has to be displaced for the width of the pile. And these piles are down at their tips are maybe a foot in diameter or so, and you've got 37 of them being driven down into a tight cluster. So the soil that's driving into has to be pushed out. Well, that pushing out pushed into the side wall of the freight tunnel and made the wall collapse. That actually all happened back in September of '91, but nobody at the time knew it.
In the 1990s, the freight tunnels were being used to run fiber optics, cable, and other utilities. In January of 1992, a couple of cable installers discovered the breach in the tunnel. They made a videotape of the hole and gave it to the city. But there was a bureaucratic snag.
In the budget that had been developed for that fiscal year, the little unit that was responsible for dealing with the tunnels got moved from one department to another department. And no one really knew who they reported to anymore, so they just put the video aside and didn't tell anyone.
Jurisdiction for the tunnels had been moved to the transportation department, and they didn't become aware of the video and the tunnel breach until March. Since they knew the hole had already been there for at least 2 months, no one felt it was an emergency. But the department did seek estimates for the repair of the breach. They finally awarded a contractor $7,000 to fix the tunnel. Unfortunately, they waited too long.
This was a serious problem that required immediate repairs, and it should have been expedited.
Local businesses dealt with the disaster the best they could.
We were trying to get rid of all of the food that we possibly could because everything was shut down, the freezers, the ovens, and everything else.
We were worried about all the people who had bought items and we're going to have them shipped to them because all those items were down in our second basement, which was underwater at that point.
Chicago was officially declared a disaster area on April 15th, and FEMA, the Federal Emergency Management Agency, began distributing funds for the repair and cleanup process. They called up the Army Corps of Engineers and gave them the mission of finding a way to quickly plug up the hole in the tunnel and temporarily contain the water flow.
Now, the freight tunnel in this location actually goes in two directions. It goes east on Kinzie Street, and it also goes west in Kinzie Street in two directions. So to plug the leak, we sank 3 shafts on each side of the river dropped in sandbags, and then surcharged it all the way to the top of the street with stone to temporarily stop the flow. 20 feet away from there, we drove some other shafts on Kenzie Street, had divers go down into the tunnel, chipped away the debris at the bottom of the tunnel. In that case, we were able to pour concrete from the bottom of the tunnel up all the way to the top of the shaft.
Once the flow was stopped, the dewatering phase could begin. More than 1.5 million tons of water had flooded the loop. As the Army Corps of Engineers pumped the water out of the loop, the mayor pulled together a team to permanently secure the tunnels.
The city hired engineers, and there was a great effort put out and a teamwork thing to prevent this thing from happening. Can we anticipate everything? No. You do the best you can, and I think that was a great example of how engineers, contractors, and the city officials and that all work together.
What we did is we've done bulkheaded every crossing at the river. So both sides of every crossing have this. And then the other thing is there's sensors in there that trigger once the water level reaches a certain height. When we get up about a foot or two, it would trigger the alarm and let us know if there's water in the bulkhead.
The people of Chicago took the whole event in stride.
We knew we had a big problem on our hands, and we worked day and night until the problem was solved.
That's Chicago. That's how Chicago works. The city that works, and it worked.
The ultimate cost of the Chicago flood reached the $1 billion mark. But in one way, the city was lucky. There were no fatalities, and in fact, no injuries were reported. On March 27, 1981, the 5-story Harbor K condominium in Cocoa Beach, Florida, collapsed while it was still under construction.
It literally pancakes.
The disastrous accident killed 11 people and injured 23 others.
What you see is columns sticking out, sticking up, and the slabs came down, stripping themselves around the columns.
The design of the beach condominium was a simple scheme that was often used in office and residential construction.
Reinforced concrete columns, flat concrete slabs between those columns, a rectangular shape. You construct floor after floor.
Because the accident took place while the building was under construction, it came under the jurisdiction of the federal government's Occupational Safety and Health Administration. OSHA immediately brought in investigators from the National Institute of Standards and Technology to determine what caused the disaster at the Cocoa Beach site.
Investigating a failure is very much like investigating a crime. You have to sift through a lot of evidence.
Their initial on-site inspection gave the investigators a general idea of what might have happened.
When we looked at the evidence, we saw that a lot of the columns remained vertical, and this told us that the floor slab had separated from the columns in what we call a punching shear failure.
A punching shear failure happens when the concrete floor slab cracks and breaks away from its column connection.
It's as though you're poking the column through the floor slab like a pencil through a piece of paper. The resistance to that penetration is a function of the strength of the concrete in the slab. And it's also a function of the thickness of the slab and where the reinforcing steel is placed in the slab.
When they analyzed the concrete used in the construction at Harbor K, the investigators discovered that the steel reinforcing bars in the 5th floor slab were placed incorrectly.
The location of the rebar in the concrete is important. Sometimes you need the rebar right under the top surface of the slab, sometimes you need it near the bottom surface of the slab.
Before the concrete was poured, the pieces of rebar were set on steel chairs to hold them in position. But in this case, the chairs were too short. The rebar should have been closer to the top of the slab to give it enough depth and strength to resist the pressure of the column.
Near the column, the tension forces are near the top of the slab. Therefore, you want the reinforcing bars as close to the top surface as possible.
It was actually 1 inch deeper in the floor slab than it should have been. As a result of this reduced height, it reduced the resistance of the floor slab to this punching shear failure.
You could have been a mistake by the people who supply the material, or somebody picked up the wrong pieces and put it on the truck and delivered. We don't know. But once we have determined that from measuring the height on the 5th floor, that was the time we said, aha, we think we know something.
Construction workers noticed cracks near the columns on several floors. They notified the engineering designer, who came to the site on March 10, 1981, just 1 week before the collapse.
The designer came, looked at it, and concluded everything is hunky-dory.
In fact, what those cracks were telling us is that there was a distress at the connection between the slab and the column.
"14 years after the Harbor K disaster, on June 29, 1995, the Sampoong department store in Seoul, South Korea collapsed. The disaster occurred during peak shopping hours. 502 people were killed, and more than 900 others suffered from grave injuries. The entire city of Seoul was in shock. Similarities to the Cocoa Beach collapse in 1981 were numerous.
Again, flat slabs, reinforced concrete columns, most likely shear punch.
The store was built in 1989, and that same year, the owners decided to add another floor to the 4-story building.
The engineer of record said, that cannot be done. We are dealing with a structure which is designed over a landfill, and we should not add this weight. The owner hired another company which said, yes, sir, we are going to do it.
The 5th floor was built, and the building stood for 5 years. The collapse was triggered when 10 tons of air conditioning units were added to the roof in 1995.
And that created stresses on the top of the structure, which was already overstressed.
Like the Harbor K structure, cracks in the concrete were brought to the Sampoong store owner's attention just days before the collapse. But they ignored the warning signs and refused to evacuate the shoppers and store personnel, a decision that resulted in the high number of deaths and injuries. Though they were in different parts of the world and collapsed 14 years apart, the Harbor K and Sampoong disasters were both the result of a punching shear failure that could have been prevented. In Korea, the store owners, Jun Lee and his son Han Song Lee, were both found guilty of negligence and bribery and sentenced to prison for 7 to 10 years. The state of Florida strengthened its construction safety laws after the disaster in 1981, requiring more scrutiny of construction plans and more on-site inspections by engineers. A.M., August 31st, 1988, a Delta Boeing 727 airplane, like this one, was cleared for takeoff from Dallas-Fort Worth Airport. The plane, bound for Salt Lake City, taxied down the runway. The pilot accelerated, lifting the nose of the airplane, but he never achieved liftoff. The right wing of the 727 hit the ground. The plane began to wobble out of control, and then it crashed. Eyewitnesses say it looked like a cracked egg.
I know people were in danger. They needed us. And the main thing that I was thinking is getting there as fast as I could.
The airport fire department arrived on the scene within 2 minutes.
It was smoking. As I got closer, I could see the fire towering between the smoke.
They put foam and water on the largest volume of the fire and quickly secured that fuselage area because that's where our passengers are at.
Of the 147 people on board, 1 flight attendant and 13 passengers died, and 16 were seriously injured from the fire and smoke that consumed the mangled airplane.
We're very fortunate that as many people survived as they did. I've seen accidents not any worse than this where everyone died.
A team of investigators from the National Transportation Safety Board was immediately assembled and dispatched to the site of the crash. They would find that mechanical failure and human error had combined in a deadly fashion.
I was with the team and the board member on scene. People sometimes think of us as puzzle solvers. That's basically what it is. You collect facts, you analyze those facts. Where do those facts lead you? They lead you to, in this case, the cause of an accident, and then you go from there.
One of the first things the investigators discovered was that the flaps on the airplane's wings were in the retracted up position. They should have been set down at a 15-degree angle to allow the plane enough lift for takeoff.
One may question, why could 3 people in a cockpit allow the plane to take off with all of them knowing that it should have been at 15 degrees and take off with the flaps at 0 degrees? And there are reasons that that occurred.
The NTSB team learned that after Flight 1141 had pulled out from the gate and the crew was preparing the takeoff checklist, air traffic control delayed the flight for an indefinite period of time. At this point, the crew made a crucial error in judgment.
They didn't finish going through the checklist.
Instead, while they waited for clearance to take off, the 3-man cockpit crew engaged in casual conversation with a flight attendant. According to the FAA, this is a violation of the sterile cockpit rule.
Sterile means there's no extraneous conversations going on. You're not talking about baseball scores or who the Cowboys are playing next week or any other kind of things that people always talk about. Stick to flying the airplane. That's all you should be talking about from the time you leave the gate until you get over 10,000 feet.
There were 4 planes ahead of Flight 1141, but air traffic control decided to give them permission to go around the others and get in position for immediate takeoff.
And you could tell by listening to the cockpit voice recorder that there was some, I won't say pressure, but they were speeding up, if you will, the process of finishing the checklist.
When it came to verifying the position of the wing flaps, the response was 15-15 green, which meant both wings were set properly to 15 degrees and ready for takeoff.
They're on, flap. 15 green light, flight control.
In our opinion, we can't answer why the individual said the 15-15 green light when we are positive that it was set at 0.
But even with all of these human errors, the 727 was equipped with a mechanical fail-safe device called the takeoff warning system.
As soon as the engine power got advanced and the takeoff warning system, then all sorts of warning horns going off saying, "Hey dummy, put the flaps down, we're not ready to take off yet."
But the warning horn on Delta Flight 1141 didn't go off.
Aviation is, the old expression is hours and hours of boredom punctuated by a few moments of stark terror. And your job is to prepare yourself for these few moments of stark terror.
There are 2 theories that could explain the takeoff warning system failure. One is that the device was assembled improperly at the factory. The other suggests a problem in the airplane itself.
There was a minor electrical system malfunction and a circuit breaker that was out that the flight engineer had detected, but he didn't think it was going to be a major problem. And he didn't calculate that that would have disabled the takeoff warning horns.
Since the crash of Flight 1141, the sterile cockpit rule is more rigorously observed.
I think all of us in aviation, we're more cognizant of the fact that it's easy to overlook things. And so you don't need any distractions.
Flight crews are more diligent about performing their pre-flight checks.
One of the things that I think more people are doing as they take the runway now is to do this additional last-minute check. Even though 30 minutes earlier they might have checked the flaps were down, check again. check again, check again.
And manufacturers have improved the takeoff warning systems throughout the airline industry.
Suddenly, to be awakened at 2 a.m. with this huge explosion, with the decks collapsing, have no earthly idea where the safety of dry land was, no life vests, no lifeboats.
It was the largest maritime disaster in history, larger than the Titanic, much larger in loss of life.
What I am always amazed by is the fact that so many soldiers died, so many men who fought for their country, and this event has been entirely forgotten by history.
On April 24, 1865, the steamboat Sultana left Vicksburg, Mississippi, heading north up the Mississippi River. It was packed with approximately 2,300 passengers and crew, 6 times the usual number for such a paddle wheel vessel. The Civil War was just ending, and most of the travelers on board were Union soldiers who had recently been released from southern prison camps.
There was barely enough room to lie down. There was one cook stove for that entire boat. So a lot of the men had to eat their rations raw. But you know, it didn't matter. They were on their way home.
On April 27th, 3 of the Sultana's boilers exploded. The force of the blast blew scalding steam and flames throughout the wooden boat. Those who weren't killed instantly jumped into the river, but most of them drowned before they ever made it to shore.
The state of boiler technology at that time was pretty crude and pretty rudimentary.
The Sultana used Elder boilers, manufactured in England. They were 18 feet long and 4 feet in diameter. Each of the boilers had 24 flues, open cylinders that ran from the front to the back, which were 5 inches in diameter.
And these boilers would have been sitting side by side, and they would have been encased in a protective sheeting.
Underneath were 6-foot-long coal furnaces that generated heat for the water in the boilers, but only for the forward portion. The 24 flues carried hot air to the back to heat the rest of the water.
So what happens is the fire heats up the air, and the air by a draft is pulled under the boilers, then through these flues, and then up the smokestacks.
The boiling water became steam, which powered the boat.
So that's really basic, way that the boilers would have worked on the Sultana or on any steamboat at that time.
At the time of the Sultana disaster, steamboats were a common mode of transportation on the Mississippi River.
The mid to late 1800s was what we call the golden age of steamboats. This was the superhighway of that time period. So you had literally hundreds, thousands of steamboats plying the waters, running short little 10-mile jaunts from one city to the next. The river was filled with those.
And when you figure that many steamboats that were traveling the rivers, in the 1800s, not one of them is left. They only lasted about 3 to 5 years.
Many of the steamboats on the Mississippi were destroyed by boiler explosions.
There wasn't much regulations on those boilers, and it was one of the real serious things to have, of course, a boiler explosion, because subsequently, if that happened, you had not only scalding water and shrapnel, you had splinters of woods and always a fire, because it also blew the furnace apart.
The Sultana was only 2 years old in 1865, but all 4 of her boilers were in need of maintenance.
They had to be fixed a number of times, and even the trip that when the soldiers were being placed on board the Sultana at Vicksburg, the boilers were being repaired because one of the middle left-hand boilers had sprung a leak down near the furnace.
The captain of the Sultana, James Cass Mason, was also one of the ship's owners. He routinely overtaxed the boilers, trying to make his steamboat run faster,
He's like what I like to call a leadfoot nowadays. He loved to race his steamboat, and he didn't have a lot of money. He owed a lot of people. He let his boilers go into bad repair.
When the Union Army was choosing a boat to carry soldiers back home, Cass Mason bribed one of the officers to let him take more than 1,300 men on board the Sultana, knowing it could be a safety hazard.
The military was paying $5 per enlisted man, $10 per officer, and that was a lot of money. And Mason was a man that was in financial trouble. He needed the money.
The trip up the Mississippi was difficult for the Sultana because the river was at a flood stage, so the current was strong. To make headway, the ship had to crisscross from one side of the river to the other.
It was going sort of perpendicular to the river and getting hit in the side with the strong flood current, tilting the boat.
As the Sultana tilted back and forth, the water in the upper boilers flowed into the lower ones. This exposed the metal in the upper boilers to the fire without any water to protect them from getting too hot.
And as this boat now tilts back to an even keel and the water flows back to that boiler, it's going to touch that red hot metal and it is suddenly going to turn into excess steam.
To keep up the Sultana's speed against the strong current, the chief engineer increased the steam pressure by tampering with the safety valves on the boilers.
What would happen is a lot of engineers would tie down the safety valve or tie weights onto the safety valve to weigh it down so when it hit 125, 130, 135, it wouldn't blow.
The hot metal, high pressure, and faulty boilers combined to cause the deadly explosion.
There was probably weaknesses all throughout the boiler, and all steam needs is one little opening and one little bad spot, and if the pressure increases, it's gone. My theory is that the one exploded, it probably sent shards of itself into the opposite two on the other sides, and then once those are punctured, then they blew up.
Today, there are still a handful of paddle boats cruising the Mississippi River, and they still use steam as their source of power.
Our boilers are fully automated, so we have a lot of alarms and a lot of indicators, so engineer can trace and see what's going on at all times. We watch all parameters, boiler parameters, steam engine parameters, electrical parameters, all equipment.
We have navigational aids. We have all this safety equipment on board. It isn't likely we're going to have something like happened with the Sultana.
News of the Sultana disaster didn't make the headlines. Other major events were taking place in April 1865.
Lincoln had just been assassinated. The war had ended at Appomattox a few weeks before, and the stories about the Sultana, if they were even in the paper, was on the 4th and the 5th page.
Even books about the end of the Civil War don't mention the Sultana. And I think it's a travesty to these men's memories and their actions for their country that they've been totally forgotten.
And as tragic as it is, there were a lot of new regulations changed after the fact to help prevent things like this from happening again.
As a direct result of the Sultana tragedy, the first boiler inspection and insurance company was formed.
You had to go to school now to become a boiler inspector, and it wasn't as easy to bribe them. That was another thing.
At the National Cemetery in Memphis, Tennessee, the gravestones stand as a permanent reminder of the soldiers that lived through the war, but lost their lives in the Sultana disaster. Accidents in 3 European Alpine road tunnels claimed 62 lives between 1999 and 2001. The Gotthard Road Tunnel in Switzerland was one of them. On October 24, 2001, in the 10.5-mile-long two-way road tunnel, a truck driver swerved into oncoming traffic, collided with another truck, and crashed into the tunnel wall.
At the end, we had the result that he was drunken. And I think this kind of drivers should not be on our road system.
Diesel fuel spilled out of the truck's gas tank and caught fire. The truck was loaded with several tons of tires that also ignited.
The fire developed very quickly. In 1-2 minutes, the fire was open fire.
Tunnel traffic came to a standstill. The two burning trucks blocked both lanes. 11 people died, but they didn't perish in the raging fire. All of the victims died from smoke inhalation.
And the fact is known that in a tunnel, the smoke is the real risk, not the fire. And not all the people were aware of this danger.
The ventilation system in the tunnel was able to suck some of the deadly smoke out, but most of it spread to the northern end of the tunnel, completely enveloping the trapped vehicles.
You know, the fire brigade was immediately alarmed.
Attention, this is a police announcement. A vehicle is on fire in the tunnel. Passage is partially blocked.
The police aired announcements over the radio to instruct people trapped in the tunnel to get out of their cars and find one of the emergency escape shelters.
Follow the emergency traffic signals to the nearest escape shelter.
In the Gotthard Road Tunnel we have these shelters, I say the rescue boats.
You will be safe in the shelter.
The tunnel houses 64 shelters. These airtight rooms are equipped with first aid kits, fire extinguishers, and instructions on what to do next. The shelters are connected to a safety tunnel, a narrower passageway that runs parallel to the road tunnel, with exits on both ends. But not everyone heard the radio announcement on October 24th, 2001. And with all the thick black smoke, they couldn't see the signs posted throughout the tunnel.
5 were dead in their cars. I don't know if the radio was on to listen what the announcement is of the police. And if you follow this announcement, there you have a good chance with our shelters to survive.
The smoke couldn't penetrate the escape shelters, but the investigation into the disaster confirmed that the ventilation system in the tunnel itself was not sufficient to handle the smoke generated from a fire of such great magnitude.
So the 2,000 meters were fully filled up with smoke in direction north because of this old ventilation system.
Ironically, at the time of the tragedy, the Gotthard Tunnel had already begun updating its ventilation system.
This system was in construction when the fire occurred, but it was not yet operating. This was another unhappy circumstances that one has to deplore.
The ventilation system in the Gotthard Tunnel is a transversal system. It consists of 4 large ducts, which are connected to 22 fans throughout the tunnel. The fans blow fresh air into the tunnel and extract the foul air out through 6 ventilation stations.
This is the system which is installed in most of the long alpine tunnels, because originally it was considered to be the safest.
After the fire in 2001, motorized dampers were added to the transversal ventilation system. Engineers cut 178 squares out of the concrete ceiling of the tunnel, 100 yards apart. Then, they installed the dampers in each of the squares. The damper blades are opened and closed by remote control. The dampers pull the smoke or foul air from a specific localized area of the tunnel into the ventilation extraction ducts.
We have the possibility to open dampers in the area where the smoke is and to get it better away from the traffic area.
In case of a fire, the Tunnel Control Center can quickly open the dampers at the site and close all the others. The smoke is extracted and then released out of the tunnel through smokestacks. Since the disaster, fire and rescue units are stationed at both entrances of the Gotthard Road Tunnel. And they have 2 new vehicles, which have several high-tech features.
Both vehicles are equipped with infrared heat-sensing cameras, which allow the driver to move the truck in the tunnel even with smoke.
The trucks are equipped with a hydraulic lift. They can be raised off the ground and rotated 360 degrees for maximum fire coverage. And now, the firefighters are able to stay on the scene longer.
We have new long-duration respiration systems, which can be put on during the ride to the incident. And the driver and co-pilots can have respiratory protection from built-in supplies within the cab as well.
The Gotthard Road Tunnel is the longest of the more than 24 alpine tunnels across Europe. It's also the most heavily traveled. About 6 million vehicles pass through it each year.
When the Gotthard Tunnel was planned, the design traffic volume a year was about 2 million vehicles. And now we have 3 times as much vehicles. So the tunnel is very overstressed by traffic. And this is mainly due to the increasing merchant traffic.
To cut down on the number of trucks and hazardous material loads in the road tunnels, the Alp Transit Authority of Switzerland has started construction of a new rail tunnel system.
The will of Swiss people today is to decrease the truck traffic and to put all these merchandises on rail.
The new Transalpine Railroad will carry both passengers and cargo, particularly heavy goods and hazardous materials.
And this rail tunnel is able to transport 300 trains a day. There are trains about 1,000 tons.
We'll have less trucks on our highways, they'll be less congested, and safety in the Gotthard Road Tunnel, for example, will increase by a lot.
The massive project will be completed in 2015. So until then, the traffic in the Gotthard Road Tunnel will continue to increase every year. But with an improved ventilation system and new safety equipment, the Gotthard Tunnel has taken significant steps to minimize some of the risk for future disasters.
This book is powerful. Millions